All right. So as we begin, we've probably heard this before. We don't have a whole lot to go over. That's why we have these 3 days to actually go over materials. And we made reference to this on Friday, I believe. Okay? Yeah, I don't know if it tastes very good either. I just thought I would mention that. I guess it's okay. I mean, it's red. I mean, yeah. Enough about that. But we did say that that university has the only law school and medical school within probably 400 miles. Where would the next closest one be? University of Nebraska, right? Or Iowa. But I'm thinking that's a little...
Does Minnesota have one?
Minneapolis, yes. University of Minnesota.
Iowa State would be closer then.
See, I don't, because Ames is Iowa State and University of Iowa is in Iowa City.
Ames is like 5 hours away.
Okay, all right. But I still would be led to believe, I suppose it's either Minneapolis or Lincoln would be the next closest ones. Okay, so what we need to discuss is we made reference to this, okay? Okay, and that is on this benzene ring, if we're going to put a halogen on there, okay, then we know we have to have a metal catalyst. And it doesn't matter. We've used nickel, we've used aluminum, we've used iron. A metal catalyst goes on here. And then we know that, okay, then probably the most common spot you would put that is here, okay? But then what happens if there's lots of this in here and we say that this is in excess, okay? So what that would mean is this process would repeat itself, okay? So we still have more of this, we still have more of this, okay?
Is there going to be excess problems on the exam?
Perhaps. That's why we're going over them. Yep. And this is still in excess. So we know, I should have started that over there. So this is going here, okay? So this has not disappeared. But then what can we presume that because this is in excess, it's just going to keep attaching wherever it can?
So it never ends.
Well, wherever it can. Once there's going to be a spot where it just can't do that because of the chemical properties, I suppose you could say electronegativities, or I think that would be the best way of looking at that. Okay. Okay, well, let's look at this because now this process has repeated itself because remember, I think there was a problem on your 5th paper that had multiple steps on here, correct? We just didn't write the excess on here. So now what we see happening, okay, this is going to tell that what to do. So now what would we see happening? Okay, so then we would see this. It wouldn't be metapara though. Yeah, okay. I knew what we meant. Okay. Okay, and then we know that now, the reason that you see this on here, you said meta or ortho and para, correct? And that would be right. So this is not going to disappear because this is just going to keep on reacting as long as you have that to react that with. So then from our original position, okay, we've got our ortho one, And then if this was a standard problem where if we had chlorine on here, this was not in excess, okay? That would be right. And then where else would you put that chlorine atom? Yeah, on the bottom, okay? And that's where we would stop because this was not in excess. But now that it is, okay, this attaches on here. And then this is going to continue. Okay, so we did step one. It's going to keep on going because this is in excess, and then does that stop from for our purposes, we're going to say, from our original position. There's one more spot that can be occupied. Why are you correct? Right, so what happens is this would be correct because this is from prior knowledge. This is from prior knowledge. It's just that this is in excess. These chlorine atoms are just going to keep on attaching because you have enough of that to keep on attaching to the ring. So therefore you had correct. Jeez. Yep. You would think we'd be getting better at drawing these by now. You ever put a ring down and said, I don't like how that looks, and you erase it and start over? No? Whatever it shows up to be like, that's what we're going with, right? Okay. So then here's our original. This was the second step. This was the third step. Then finally, there we go. There's no, for our purposes, we want you to learn and understand that when you chlorinate this, and then since this is in excess, this just keeps on going from our first position, because what you could say is, who's to say that this chlorine atom isn't forcing one to go on here and here? And that might be correct because that is something that you don't remember, but I'm willing to bet that some of your parents do. Okay, let me find this quickly. So with that little tangent, I looked in the book. I think it's a cycloalkane that is a six-sided figure, not benzene that has all those chlorines attached. It was called lindane at one time, and it worked very well, but I think it's been outlawed by the FDA now. But for our purposes, again, starting with benzene, this chlorine, there's lots and lots of chlorine in excess. So wherever it is that you would attach that, since that's in excess, it will continue to attach wherever it can. And we would take that in phases, okay? So you chlorinate it first, and then from prior knowledge, we would say, okay, this is an ortho and para director, which it is. So then here is your ortho position, and that stays there because, again, this chlorine is in excess. So since that's still there, okay, then notice from our original position, we go down to here. Then there's only one other spot left in accordance with our original position, and that's right here. Okay, there wouldn't be a lot of those on there because this is really, really, really high order thinking.
So, but on the exam, both of them will be excess.
Yes, you would have to presume that.
So will we just do are we gonna have to do that whole problem?
Perhaps.
Some of it filled out.
So if your second equation didn't say excess, you would stop after the second.
You would have this one
And the second one.
and then this one without that on there. That's correct. Yep, because that's how we learned it before, because that's what halogens do. They direct it to be here and down there. But since this is,
Excess, so it doesn't stay.
that's correct. Okay, so that again is some pretty high order thinking. So for part one, just basically know how these attach onto the rings, whether they're ortho or para directors, okay? And for instance, what happens when we do something like this, and I think you know what the answer is. Okay. If we have ethylbenzene, okay, if we're adding some chlorine to that, this is a lot different than that, okay? Just because of the catalyst that we have, why does this make a difference?
Because heat combines them.
Okay, you are correct. The heat is going to do this, and this is easy to do, okay? We're going to see this happening because it is so easy to do. Somebody is going to do that, and that is wrong, okay? So how that's right, but how could you even make that more sense if we're saying, well, how can this be wrong? We said that heat causes this chlorine to attach on there. Yes, I agree, it does, okay? But if we were to look at the structural formula then, which is fine if you still do that, because maybe for some people that makes more sense. Here is our C2H5, but then the moment you say C2H5 and then Cl attached again, that's too many bonds for those carbons. So then that's why we say C2H4, 1, 2, 3, 4, and then the Cl. I mean, it's always going to work if you use the structural formula. If you use the molecular formula instead, that works, but you just have to be aware of that. Okay? But that's if heat is added, but if it's just a metal catalyst, that is altogether different. Okay? So here's our C2H5. Then what happens? Yeah, it's a different pathway according to our chart. It's not going to cause that to attach here. It's going to go here is one, and then there is the other. Okay. So we just wanted to make sure that we covered that what happens when these are in excess. It just keeps attaching to the ring, providing it has to go in specific spots because, again, this is an ortho and para directory. And in accordance to this, it'll go in 3 spots. We said this one, because that's an ortho position. This is maybe a little more familiar again. That's the para position. And then another ortho position. And again, this is all in accordance to the original chlorine that we put on there. Okay. Then the last thing I want to go over is because a little bit of, what's that called in plays or movies or whatever, where you kind of see what's going to happen in the future? Is that foreshadowing? Is that what that is? Okay. So what we mean by that is foreshadowing. So this is making reference to the alcohols, okay? And that is we know that these are isomers of one another. And we could put isomers on there if they are alkenes, but what we mean by this is how many carbons is that when where X marks the spot? How many other carbons is that attached to? I mean, how many carbons attached to this one? 1. And you would think so. We're not counting the rest. I didn't explain that well enough. It's where, when you say X marks the spot, how many other carbons are attached to that, okay? So it's 1, so we just say that's primary. That's a primary carbon there, okay? But then, should we move this over where X marks the spot there, how many carbons are attached to that, okay? So then, we've seen a butyl derivative like that where it attaches to the second carbon, in, what do we call that? Blank butyl.
S.
Yeah, S, or secondary butyl. So that means this is a secondary carbon. And the reason that we have this over here, if we say X marks the spot, okay, then according to your butyl derivatives, this would be a tertiary carbon, okay? Okay, so if it attaches to one carbon, it's primary. If it attaches to two carbons, it's secondary. And if it attaches to three, then it's a tertiary carbon. I just wanted to go over that before. There might be something similar to that. No, you wouldn't have to draw. You just have to interpret it. The reason I say that is we've seen questions on your exam before for multiple choice, and that would be, see, how do we, let's say, a multiple choice question would say something like, if an oxygen is attached, no, it is attached, but I want to say this, is double bonded to the end carbon, that is a or an blank. So that's what we mean. We want you to look at this and maybe draw out what is it saying. So if we have a double bonded oxygen on the end carbon, how many carbons do you want to see? It could be 1, 2, 3, 4, you tell me. Okay? So it doesn't matter how many carbons you put in the chain, okay? If an oxygen is double bonded to the end carbon, okay? So there's our double bond. What organic family is that?
That's not S. Oh, no, that's a key, no, that's the, aldehyde.
That's an aldehyde. So that's what we mean. You could have questions like this. You've seen them before. And if you have to draw the structure out, go ahead and do that. Because you might not be able to visualize that in your head, but once you draw the structure out, then it makes more sense. Okay, that's all I have. We will catch up to you next time.